Welcome students, we are expected to integrate this question integral 0 to pi over 2 dx over 1 positive tan raised to the power of root 2 x. Now this looks really complicated. This is a Putnam integral, but it can be simply solved within 2 minutes. Now foremost, what I wish to do is I would like to take let I be equal to integral 0 to pi over 2 dx over 1 positive tan root of 2 x. Actually the root 2 is raised as an exponent here. Now what I wish to state here is a property. We know that integral a to b, it's a property in definite integrals, is equal to integral a to b f of a positive b negative x times dx. This is a very crucial property. As I mentioned to you in one of the problems, this property is used to solve many of the complicated integrals. So by this property, I'm going to rewrite this to be as integral 0 to pi over 2 dx divided by 1 positive tan raised to the power of root of 2. In place of x, it's going to be 0 positive pi over 2 negative x. Now let us consider this quantity, right? So this is going to be tan root of 2 of pi over 2 negative x. Now if you were to just take tan of pi over 2 negative x, I can rewrite this as sine pi over 2 negative x divided by cos pi over 2 negative x. Now sine pi over 2 negative x is nothing but cos x, and cos pi over 2 negative x is nothing but sine x. So I can rewrite this as 1 over sine x divided by cos x. Right, but this is nothing but 1 over tan x. So I started with tan of pi over 2 negative x, and I reached at a point 1 over tan x. Now if I were to raise it to the power of root 2, this is going to be 1 over tan raised to the power of root 2. Simple as that. So I'm going to use that same concept over here. So this is equal to integral 0 to pi over 2 dx over 1 positive 1 over tan root of 2 x, right? So if I were to take the LCM and rewrite this, this is going to be 0 to pi over 2. Taking the LCM in the denominator, I would get tan root of 2x positive 1 divided by tan raised to the power of root 2x. I can flip it. That's going to be tan root raised to the power of root 2x times dx. So this is equal to I. Now already we have taken the initial given question as I. So if I were to add, so let me take this as 2 and let me take this as 3. Adding 2 with 3, okay, we get, what do we get on the left side? On the left side we will get 2i. On the right hand side it's going to be 0 to pi over 2 dx over 1 positive tan raised to the power of root 2x positive integral 0 to pi over 2, this quantity, tan raised to the power of root 2x divided by tan raised to the power of root 2x positive 1 times dx. So if I were to add these two integrals, I can rewrite this as 0 to pi over 2. This is going to be 1 positive tan raised to the power of root 2x divided by, denominator is common, 1 positive tan raised to the power of root 2x times dx. So clearly the numerator and the denominator can be cancelled, giving me integral 0 to pi over 2 dx, which is nothing but x raised within the limit 0 to pi over 2. I substitute the upper limit minus the lower limit, I get pi over 2. On the left side I get 2i, so therefore I is equal to pi over 4 is the solution. Thank you students, enjoy your day.